So hi everyone, my name is Jessica. I'm doing my PhD at the Australian National University, and today we'll talk a little about how landscape features can influence the genetic diversity of lizards in Australia. So species recent distribution reflect the special patterns that influence the gene flow over time. While gene flow contributes to species' capacity to adapt to an environmental change, disruption of the gene flow can reduce the genetic diversity, adaptation abilities, and also restrict the distribution of these species. But what exactly can limit the gene flow? Well, it's basically anything that limits the species reproduction. It could be environmental barriers as rivers and mountains that will not allow a species to move across an environment, or even climatic as precipitation. Could be physiological barriers as water and thermal tolerance. And could be just a result of the distance. So if two individuals are really distant from each other, they will not be able to match and reproduce. Also, life history elements can influence the gene flow based on the dispersal abilities of different species, competition, and also the habitat specialization. So, if a species has limited dispersal abilities in response of its habitat specialization, we can observe some general patterns. So here, for example, we'll have 3 different species of lizards that occurs in Australia, and what we can see is that species that are more generalist tend to be a bigger distribution and lower number of lineages when you compare to more specialized ones. However, we have this picture in the macro scale, but little is known about the effects of the fine scale topography on the abilities of the organisms to move among habitat patches. What can make us ask things like how gene flow is facilitated or inhibited by environmental barriers for species with different requirements. This is true for high heterogeneous environments as the one in the Australian Monsoonal Tropics. So this biome is situated in the north part of Australia, as you can see in the map. This is a savanna-like environment with a really distinct wet and dry season and a fixed fire regime. And some geological features as the Arnhem Land and the Kimberley Plateau contributes to the complexity of this area. So we usually divide this area in 3 different regions. So the Kimberley, which is the one with the waterfall picture, it's a more arid area. We also have the Cape York that is in contact with the wet forests in Australia, and the middle one that is the top end region and the one that we will be focusing today. So in this work, I selected species that occurs all around the top end for 3 different families. So we have the rainbow skinks of the genus Cardia, the true lime dragons of the genus Deporifera, and the talageckos of the genus Gehara. So I selected species that was that are quite generalist in their habitat specialization, and also species that just occur in small rock patches along the environment. So for all of these genus, we have species that are really specialized in their habitat, so just occur in big escarpments or restricted to river margins. But I will not talk about them today since they have really small distribution compared to these species. So, so I collect information about distribution and habitat for all the species that I was interested in, and based on extensive data of mitochondrial and exocapture, we use some lineage delimitation programs like BGMSC to choose the species that I was going to target in my SNP sequencing using the DART, the diversity arrays method. Okay, so with this my SNP data, the first thing that I do was just a principal coordinate analysis. This is a really easy way to visualize the structure that you have inside each of the species that I selected. As you can see on this map, we can see that the species are that the different populations are not interact a lot, so they present like really high structure. And because of this, I decided to focus on the different lineages and not just on the species. So here's just an example. So if you take a look at the gecko data, you can see that the generalist is the one that is distributed all around the top end, while we have this pattern of the different lineages that occur just on the or the west top end. You can see the same for the periphery, while this pattern is not so evident on the skin data. And this is probably to a population expansion already reported by Potter and collaborators in 2016. So my first question does habitat use affect the rate of dispersal across the scope of environmental? So using all these lizards in this area, I believe that species that are specialists would have a stronger relationship between the geographic and genetic distance compared to the woodland or more generalist taxons. And here in this picture, we can see in the first graph the isolation by distance plot by habitat specialization. So we can see that generalist species tends to have higher genetic diversity when you compare to the specialist ones. This is probably because of the population size that is bigger in the species. But if you take a look at the slope, you can't really see any big difference. And this is the same when we split the data between these different families for the snakes, geckos, and dragons. So I reject my hypothesis because there's no pattern that we could observe. So then I looked for how the landscape features could influence the ability of dispersal of these species. And for these, I performed a genetic west coast path analysis using, it's wrong here, sorry, it's 0.3 degrees of resolution. When I got information about topography, like roughness and slope, Euclidean, which is basically the isolation by distance that I showed before, precipitation and temperature, and after that I performed a regression to see which one was significant for each of my species or lineages. And it's basically what is showing in this map here. So it will just take the cost that a species needs based on these environmental gradients to go for one point to another. So my hypothesis would be that the environmental resistance is more evident for small rock specialists when you compare to the generalist woodland taxons. So looking just for the species that are habitat generalist, we couldn't see any of the environmental barriers that is selected. Doesn't seem to be influenced on the gene flow and the dispersal of the skins all around the top end. This could be just because they are just like the gene flow is occurring all around it, or maybe I didn't select one of the environments that could be limiting this. For the geckos, we saw that this flow was limiting the gene flow in both west and east top end and precipitation on the west top end. And for the dragons, we could see the east top end, just on the west top end, we could see the Euclidean and the temperature as limiting of their dispersal. If you go and take a look on the specialist ones, we can see that on the west top end for skins, it still continues to be linked to gene flow, while in the east top end we have the isolation by distance, the Euclidean distance and the temperature as limiting. For the geckos, the topography seems to be important again. And for geckos, it would be the Euclidean temperature precipitation. So what I really want you to focus is that for the habitat generalist, we can see that a few features can influence, can limit the dispersal, but there are not as many as on the specialist species. That was exactly what we were expecting. So we can see this pattern where in the east top end, the resistant models that we select don't explain are not limiting the gene flow into species, while in the west top end, different resistance models are explaining the genetic, the gene flow of different species. And this could be just because these species have different histories, as mentioned by Catherine in her amazing talk in the morning. So basically, to conclude, does habitat use affect the rates of dispersal across a common environment? There is a tendency of more landscape limiting the specialist, but not a clear pattern. And what we really want to do now is to do more study in the species level, not just on the lineage, and try to compare. And how landscape features influence the ability of dispersal of these species. We found that none of the selected landscape features seems to explain the east top end lineages, while different features influence the lizards in a different way. So basically, we believe that the intermediate dispersal rates are important to maintain the metapopulation viability, because, since it allows the divergence and hence endemism of all these lizards. And this will promote the geographic structure of the species diversity in this really diverse region. So I want to thank you, the Ecology and Evolution Division at Australian National University, the Australian Biological Resource Study that for the grant team for today, and also the Moritz, Webb, and Jane.